So I'm a research scientist at CNRS. I've been in machine learning for the last 20 years. But today I will not talk about really machine learning. There will be no equations on my slides. I will be rather talk about management of data science and how to manage data science in particularly in scientific projects, but also beyond. So I'm the PI of this project called the Center for Data Science in Saclay, which is a network of about 350 scientists. Half of them are data scientists, half of them are data providers, and the mission is to get them work together. This is the landscape we are trying to organize. So it has three poles: the data scientists, the experts, the domain experts. If you're in a business, that would be the business unit, and the engineers that build the tools. And there are a lot of misaligned motivations in this landscape. It's partly understaffed, especially at the intersections. So our mission is to actually try to lubricate those channels between these communities so data science goes into domain sciences faster. Our bet is that, of course, there's a lot of value in the last deep learning architecture, but there's more value in actually getting those architectures to work for either businesses or scientific projects. So we have a lot of different tools. The one I will talk about today is found, its place is on the bottom. So it's a tool that will give possibility to domain scientists to use data science tools like scikit-learn, etc., without actually becoming an expert of data science. So we are building management and software tools to accompany projects, starting at the definition phase, because we have to be there to make sure that everything goes right. The first part of CDS was about design of these tools. Now we are more about generating projects. We're running this CDS more or less like a scientific studio, which is a concept we borrowed from the startup world, where we are not financing full-blown projects. We are giving them a possibility to meet people, find the matches, define the problems, and then ask for money from the usual sources. The particular tool I will talk about finds itself in the world of data challenges. So if you know Kegl, this is a good starting point. Now, we did a Kegl challenge. We organized the Kegl challenge 3 years ago on physics data. It was one of the biggest one at that time. It generated a huge buzz. We had 2,000 teams working on the solutions. It started a very nice dynamics between particle physics and machine learning, but we saw very little outcome in terms of a pipeline or a product or code that we could insert into the analytics pipeline of the physicists. It turns out that data challenges are mostly human resources and publicity events. So companies hire data scientists through these challenges. The data scientists build their CVs, and they build buzz. But there is very little outcome. So what we decided to do around 3 years ago, so after this challenge, is to try to build a tool which looks like a data science tool, but instead of just having buzz, we want a prototype at the end of the challenge. It turned out a very good teaching aid too. I will explain why. And at this point today, we are actually turning it into a sort of data science team management tool, which you can imagine the team will be the full crowd, but it can also be a local team. And the tool is not very different in these two cases. So this is the team of superstars, especially if you look at their pay compared to what they could get in industry. The main thing we changed on the Kegl scheme is that participants submit code, not predictions. What happened in the Higgs challenge that we organized, that we have, of course, we had all the predictions, but that didn't force people to code in the right way. We could get their open source code, but the winner actually wrote a deep learning library in Lisp. We brought him over to the lab, and even after 2 weeks, we couldn't compile his code. So by asking people to submit code, we make sure that that code compiles, that runs, and we can reuse it. So otherwise, it's the same as Kegl. The thing is that the backend is much more complicated, of course, because we have to train the models. So if it's deep learning, we have to run it on GPU servers, etc. But it lets us deliver a working prototype at the end of the challenge. And it also allows people to participate, to collaborate, which is very important. They collaborate through code. They can read each other's code. They can reuse the code. We actually encourage them to do this. And this makes it possible to increase the score very rapidly compared to a pure competitive setup. So we've been working on various scientific topics like astrophysics, climate science, brain imaging, ecology, and a lot of different types of workflows. So we are not restricted to simple classification or regression models. We have functional data, time series forecasting, data augmentation, a lot of deep learning challenges, especially today, and different kinds of losses, etc. So some statistics. So right now we have 16 challenges that are on the site, 31 events. Why it's not the same number? Because we can use the same problem to run different events. So we have one-day hackathons, nice networking events. We can have normal challenges. One is running today, so I will talk about this. And we also use it in classrooms. So a lot of training, because students love this, because they have this competitive phase, so it's kind of like a game, but then they also see what the others are doing, so they learn from each other. This is one of the most complicated workflows we built for a use case, a real almost semi-industrial use case. It's a quality control in hospital for delivering chemotherapy drugs. They get to measure what's inside the solution using a laser spectrometer. We get a spectrum, and they want to know what's inside the solution, what is the molecule they are administering to the patient, and what is its dose. It's important before administering these drugs to know this, because if you miss the chemotherapy drugs, it can kill the patient or just not cure it. So this was a complicated workflow. We had a classification for finding the molecule, and then a regression to find the dose, 2 feature extraction steps that were not necessarily the same for the 2 tasks, and the score that had to combine the 2 objectives. So this is one of the success stories in terms of like a publication coming out of it. We also have time series forecasting, which is especially hard on a Kegl type platform, because you sort of have to give the labels if it's an autoregressive time series. So we also have a workflow for this. Use it in climate science challenges, for example. So this is I will stay on this curve a little bit because it explains, a lot of advantages of this setup. So the blue dots are, all the dots are submissions. So this was a group of about 100 students at Polytechnic, not necessarily experts. They are very good students, but they were not data scientists by far. So each dot is a submission. The score is the higher, the better. It was like accuracy. The blue dots are in the competitive phase where code was closed. For students, we introduced this possibility because we have to grade them, right? And the red dots are in the collaborative phase. The pink curve is the current best test score, and the green one is the combined test score. So we also blend the models, as everybody does it on Kegl. So what you see here is, so first observation is that in the competitive phase, the score increases. In the collaborative phase, the score increases. So that phase does help in terms of improving the model. The other thing is that you see this accumulation of like mediocre models at about 0.65. This is what you could achieve with a well-tuned, hyper-opted deep learning, the deep neural net, okay? This means that the task in this particular challenge was beyond what deep learning can do today. There were human feature engineering, so all the little blue dots that you see above these curves as the students who read the notebook, who understood the data, and who engineered features that deep learning couldn't find alone. So this is an important message if you are in this business. The other thing you see that in the competitive phase, the combined model, the green curve, opens from the best model. Why? Because these are diverse models. Students don't see each other's code, so they develop perhaps different directions. So we call it the diversity gap. Once you open the leaderboard, so people can look at each other's code and reuse the code, what you see that everybody catches up, but you also see a little bit of improvement even above our algorithmic blending. So that means that humans even can blend better than machines today. So if you are in a business where every % makes you €1 million or €1 billion, then these things are important. So this is a histogram of scores. The blue histogram is what you get in the competitive phase, sort of a Gaussian, normal. You have some people that are good, most of them are in the middle. And the red, the skewed one, is when they catch up in the collaborative phase. So this is the goal of teaching in a certain sense. So we really like this. And it's sort of reproduced on every challenge we did with students. This is the communication pattern. So since we control everything, we can actually record what people look at what code and what code are they using. We actually ask them to reference and give credits to code that they reuse. So you see the black dot, that was a submission that made a big jump in the leaderboard. So everybody started to look at it. And after that point, everybody is reusing that submission, right? This is like gold for social scientists who are studying these behaviors in a collaborative framework. So we collaborate with them too. So one announcement, we have an ongoing challenge. This is the first one with the money prize. So far up to now, it was more like a scientific project, but here we got some sponsors. It's an image classification challenge. We have 70,000 insect images, about 400 classes. Distribution is very skewed. If you do one-shot learning, that's probably what you will need here. And we also control the resource use, which Kegl cannot do, okay? So we give every participant 50 GPU hours. They have to stay within that limit. So they cannot just, fire up the biggest cluster they can have and solve the challenge. We also have a single-day hackathon next week. Oh, this is image detection now, so it's not classification. It's satellite images orbiting around the Mars, taking photos. And we want to replace the planetary scientist graduate student who has to sit in front of these images and circle every crater. So we have nice labeled images, but they want an automated detector to do this job. And it's image detection. So if you are a business around detection, not only classification, that would be an interesting event to attend. So in the last part of the talk, I will talk a little bit about preparations of this ramp, because it's nice to have it already done. It's really nice for the participants, but in the beginning, it took us a lot of time to build the workflow, make it sure that everything was fine, nothing was crashing, etc. So in the last year, we started to migrate, to build a code which was helping us to accelerate this process. Again, if you're in a business, this is huge, because most of the time you will spend on actually building the workflow, not on optimizing it. So one lesson we learned, that if we separate the workflow building from the optimization, that helps a lot, because often if you don't do this, you start optimizing something that's still fuzzy. You don't know exactly what you want to do. Scores are not set up correctly, so it's hard to benchmark. Right now, the two steps are separated, so it's clean. If you're in a business, that's again, we consult a little bit too. One advice I can give, that before you actually start getting the data scientist on your deep learning solution, put your workflow into production. Prototype on the production pipeline. I know it's hard, but you gain a lot with this, because most of the prototypes today end up in the waste basket, okay? It's a world where the data scientists are building POCs, and they're just building POCs, and they never get productionalized. So we have one open source library and another organization. The library is all our tools that we are using to build ramps, so I will have a slide on that. So it's designing workflows, metrics, cross-validation schemes, data readers, etc. That you can, once you build it, you can test it with a single command line script. And the other is an organization where we collect all the starting kits we have. So all the workflows we have built, this is all open source, and you can look at them. So this is what we achieved, actually. So right now, if you want to build your workflow, all we have to provide is a single Python script that describes those elements that you see on the bottom. So the data connectors, which can be difficult. We usually just read CSV files, but in industry it can be more difficult. Workflows, so workflow elements and how all these workflows connect to each other. Very important, cross-validation schemes, how you do the experimentation, it sometimes really matters. And of course, the metrics that you use to quantify your workflows. So if you want to use this, you can participate in RAMs as a data scientist, like Kegl. If you are in training, so you're teaching, for example, you have a course in your company or elsewhere, you can use the RAMs that are there already. You just have to ask for an event and then negotiate with us for research use if it's one of the bigger one, like where you need to use GPUs. But most of the challenges are really light, so it's not an issue. You can use the libraries that I showed you for build your own workflows, perhaps just for you, perhaps organize a data science team in your company. And of course, if you do this, then it's really easy also to make a data challenge if you want to do this. So it depends on, what your business wants to do. If you want to make, it's really important to get the last percentage out of the score, it's probably something that's worthwhile. Okay, so here are some links. The first one is the site. The second one is the GitHub library. The third one is the GitHub organization with all the kits. We have a Slack channel, a Slack team with channels around all the ramps. I'm blogging a lot, actually, on not necessarily technical questions, but more organizational management questions around data science and predictive workflows. And you see my mail there. Thank you.